All right. Today we are going to be moving on to section 2.3, and we're going to be looking at derivatives, as we will be for the next several weeks and months. And today we're going to talk about something called the power rule. The power rule for derivatives is going to be kind of a shortcut in computing these. As you noticed from the last assignment, it can take a long time to get through just one single derivative. So it turns out there is some shortcuts. So as we saw in the last video and the last assignment, that can be a bit time consuming. There's also a lot of error. If you just add one number wrong or something, then one little mistake in a big computation can mess up the whole derivative. And we really didn't do any very complicated derivatives either. We just looked at some really small basic polynomial functions. So fortunately, there are shortcuts for calculating derivatives. There are many of them. Today we're going to look at the first few of them, and probably the ones that you'll use the most. You'll use these to the point where you won't have to memorize a rule or anything. This is just going to be, oh, you calculate a derivative this way, and it's just sort of a learned technique. So let's go ahead and start with the power rule. The power rule says for any real number r which is not equal to 0, the derivative of x to the r equals r times x to the r minus 1. So if you remember, this d over dx is just one way to notate a derivative. Other ways are like y prime are the two most common ways, or f prime of x as well. So it says the derivative of x to the r. What does this mean? This means, for example, the derivative of, let's say, x to the third equals, so in this case, the r is 3. It's not 0. So we write it as 3, that's r, x to the, and then we do 3 minus 1, which is 2. So the derivative of x cubed is simply 3x squared. That's our answer. Now, as you can see, that was way, way easier than actually doing the limit definition, which would look something like this. Limit as h goes to 0 of x plus h cubed minus x cubed over h. We would then have to multiply the x cubed thing all the way out, and then eventually cancel the h's and all that stuff. This was way easier, right? So essentially what we've done in words, in other words, if you want to find the derivative of an x raised to a real number power, could be a decimal, it could be a fraction, it just has to be a real number that's not equal to 0. You simply bring the power down in front of the x, and then you subtract 1 from the exponent. So another example would be like, I'm going to find the derivative of, say, x to the 7th. Well, that's going to be 7x to the 6th. We bring the 7 down in front, and then we subtract 1 from that to get our power. That's all there is to it. Just two other notes to sort of add on with this, and that is the derivative of a constant, c, it's always going to be 0. So like, for example, if I want to find the derivative of 8, just the number 8, well, that is 0. And if I want to find the derivative of just x, well, that's 1. The reason being is x is really x to the first power. So that would be like 1x to the 0. Anything to the 0 power is 1. So just 1 times 1, or just 1. So that's why that is the case. All right. Let's go ahead and try a few problems using this. So find the derivative of f of x equals x to the 7th. I'm going to use a few different notations so you get used to these. So we could say f prime of x equals, and then we just bring the 7 in front, and then we subtract 1 from the power. So 7x to the 6th. If we're to find x to the 50th, well, that's going to be f prime of x equals 50x to the 49th. That's simple. Okay, let's get a little bit harder. Here we have an x in the bottom of a fraction. So what we're going to want to do here is rewrite this as a negative exponent. So this is equivalent to x to the negative fifth power. You really do need to be sharp on your Algebra 2 and pre-calc skills in order to get these off the bat. But just remember, if you have an exponent in the denominator, to bring it up, you make it negative. So then f prime of x is equal to negative 5x, because we bring it down in front. And then we subtract 1 from the exponent. Your temptation might be to write negative 4. That's not the case. We got to subtract 1, so it is the negative sixth power. We also don't want to leave our answer like this. Just as a general rule, we want to write the answer in the same way that it was presented to us. So in the same way that if you were given a problem with fractions in it, you would want to write your answer as a fraction. If you were given your problem with decimals in it, it would be okay to write an answer as a decimal. In this case, if we're given a problem with positive exponents, we should write the answer with positive exponents. So then just to rearrange this negative goes to the bottom of the fraction. It becomes negative 5 over x to the sixth. This is the correct answer. Oops. That will not be how it's written on AP test. This is a very simple problem, so you probably won't have this simple of a problem on the AP test. But if it were on the AP test, if you were given 1 over x to the fifth, you would not see the answer written as negative 5x to the negative sixth. It's not happening. So be very comfortable with those. All right, another one. This is a rational exponent. Rational just means a fraction. So in order to find this derivative, we first need to write this as a rational number, the exponent. Remember when you do this, if you have any x to the n with an m root, and you could interchange those, doesn't matter. The way that I remember this is that the top equals the power and the bottom equals the root. And actually, I think these actually go in the opposite direction. X to the m. Yeah. So to go from the nth root of x to the m, this would be x to the m over n. So the top is the power, meaning the top number on the fraction, which would be the m, goes to the power, and then the bottom number goes to the root. So be very comfortable with that as well. Those are just basic Algebra 2 skills. So this would be the same thing as x to the 3/4 power. Okay, so remember you could also write this as x to the third to the 1/4, right? Would be another way of rewriting that. And then when you do a power to a power, you multiply. 3 times the fourth is 3/4. A way you could self-check there. All right, so then computing the derivative, we bring the power down in front, so it'd be 3/4 x, and then subtracting 1 from 3/4, that would put us at negative 1/4. So 3/4 x to the negative 1/4. All right, now again, we're not given a problem with negative exponents, so we should not write our answer with negative exponents. So let's see if we can rewrite this. This is going to be 3/4. And when you write this, the 3 can go on the top of the fraction. The 4 should go on the bottom of the fraction. And this is x to the negative 1/4, so it would be the same thing as x to the 1/4 on the bottom of the fraction, like that, right? Okay, now we're not done yet. Still, we got rid of the negative, but we did not get rid of the 1/4. We need to write that as in root form as opposed to a rational exponent form. So then the 1/4 power, that's the equivalent to the fourth root. So this would be 3/4 times the fourth root of x to the kind of the first power, because at the top would be the power and the bottom would be the root. So the root index is 4. The power would just be 1, which we don't actually write there. So that would be how you'd want to write your answer. Try to do that as much as you can on these problems. All right, a couple other rules to throw in here. Very similar to the properties we have with limits. If you were to find the derivative of the sum or difference of two functions, so for example, if you wanted to find the derivative of 3x squared plus 5x, well, you simply just find the derivative of each of those terms individually. So you would find the derivative of 3x squared, and then you would add the derivative of 5x. Just saying that you can split apart these derivatives. So the derivative of f of x plus or minus g of x is equivalent to the derivative of f of x plus or minus the derivative of g of x. Kind of what you'd think. And we apply that rule a lot. We don't actually write it out that often, but we do apply it on all of our problems. And the next rule is the derivative with a constant in front of a function. So that would actually be the case, just really 3x squared. What you can actually do is bring the constant out in front. So this becomes 3 times the derivative of x squared. This is another rule that we use, but generally we don't actually write it out. You'll just sort of get the hang of that's how it works. But those are true properties. Okay, so let's apply this. Another thing to note is that when you're doing something like the derivative of this last one I just did, what ends up happening is it becomes 3 times 2x, which in effect just you're multiplying 3 times 2, so it becomes 6x. So in other words, when you have a derivative like 3x squared, essentially what you just do is you do the power times the number in front. So 2 times 3 is 6, and then subtract 1. So it becomes just 6x to the first. All right, let's try a few more examples on this. All right, find the derivative of f of x equals 5x cubed minus 2x squared plus x minus 8. So essentially what we're doing here is we're finding the derivative of each of these individual ones, but practicality-wise, that's not what you're actually ever going to write out. I will write it out here just to illustrate the properties, but not actually going to ever do this really. F prime of x would be 5 times the derivative of x cubed minus 2 times the derivative of x squared. We did a very similar thing to this when we talked about limits. And if you think of a derivative basically as just a giant limit, well, it kind of makes sense. Because as we saw, computing a derivative is actually just taking a giant limit. All right, so this is essentially what we're doing, except we're just doing this all in our head, knowing that we can do this. And when we do so, we get 5. And then for x cubed, it becomes 3x squared, right? Which in effect just becomes 5 times 3. We'll just go through the process. This 2 stays out here, and then the 2 comes down in front for the power. So it becomes 2x to the first power. The derivative of x is just 1, so plus 1. And then the derivative of any constant is 0. In reality, you don't actually write minus 0, but that's what the derivative is here. So our final answer then would just be 15x squared minus 4x plus 1. And if you tried to do that using the limit definition, that would get pretty ugly, take a long time. So thankfully, we do have these shortcuts. All right, so I'll treat the next one more as just skipping all the properties and just applying them to the problem. I just threw in a different variable here. It's f of z, works the same way. But you will see different variables throughout calculus. Often you'll see s for position. S of t is a very common one. S of t, v of t, a of t for position, velocity, and acceleration, which we'll probably talk about in the next video or two here. So before we get started on this f of z, let's first rewrite this so that we have a rational exponent. So this becomes f of z equals 2z to the negative 1 power plus 4z minus 2. So then f prime of z is equivalent to, we're actually essentially just going to multiply that. negative 1 times 2, so it's negative 2z, and then we subtract 1, so it's negative 2z to the negative 2. Plus, now 4 times z, 4z, the derivative of z is just 1, so it becomes just essentially 4 times 1, which is just 4. So you'll also just notice patterns like if you have the derivative of 3x, well, it's just 3. So the variable sort of drops off. And then the derivative of negative 2 is 0, so we just don't write anything. And then just rewriting this with a positive exponent, this becomes negative 2. The z has to go to the denominator, so negative 2z squared plus 4. Our final answer. Let's look at maybe 2 more problems here. Throw in some more roots for you. Actually, I think we got 4 more actually. All right, so the next one, this one notice is already written in rational exponents, so it's okay if we give our answer in rational exponents. So f prime of t, sorry, it's changing. F prime of t is going to be, we're going to multiply this down, so we have 3 times 1/3. I'll go ahead and write it for this one, but you can probably do that in your head. And then we do 1/3 minus 1, which is negative 2/3. And then we have minus 5. We bring this one down, multiply it, negative 3/4. T to the negative 3/4 minus 1. You have to be able to do that without a calculator. At this point in calculus, this would be a non-calculator question. So you're simply just subtracting 4/4. So negative 3/4 minus 4/4 is negative 7/4. All right, and then let's just reduce this a bit. 3 times 1/3 is 3/3, which is 1. So it's just t to the negative 2/3. Over here, with negative 5 times negative 3/4 becomes a plus 15/4. T to the negative 7/4. And again, since we were given the problem with rational exponents, it's okay to just leave it that way. But in most cases, you'll want to rewrite it into root form. Okay, look at the next one here real quick. This one we haven't talked about what to do if you have a fraction yet. It turns out there's another rule called the quotient rule, which tells us how to do this. But this one, we don't actually need a separate rule because you could actually just rewrite this first. So that's what we're going to do in a problem like this for now. And really, you wouldn't need the quotient rule for this one because it's pretty easy if you just rewrite it first. So all we're going to do, since all of these top terms have the same denominator, we're simply just going to split them up. So we're going to rewrite this function as f of x equals 4x squared over 3x minus 3x over 3x plus 2 radical x over 3x. So they all share that denominator. We then are just going to reduce them before we even try to do a derivative. So this becomes 4/3 x to the first power. That's 2 minus 1 is 1. The next one, this actually, just these cancel and these cancel. Now it doesn't leave you with 0, it equals 1. So it's minus 1. And then plus 2/3. You might struggle a bit to do this in your head. What we've got happening here is that's an x to the 1/2 power. On the bottom, we got x to the first power. So it becomes x to the 1/2 minus 1, so it's negative 1/2 power. So x to the negative 1/2. Now that's just rewriting it. We haven't actually taken the derivative yet. So then f prime of x, 4/3 x, well, that would actually just be 4/3. The x just drops off because really we're multiplying it by 1. 4/3 times 1 is 4/3. Sorry. The negative 1 goes away because the derivative of a constant is 0. And then the last term, we're going to multiply the negative 1/2 times 2/3. So that becomes minus negative 2 over 6. Oops, sorry, just minus 2 over 6. Don't want to up with negative. X to the, we subtract 1, so it's negative 3/2 power. Don't want to leave it like that because we weren't given it in a rational exponent form. This becomes 4/3. And then that has to go to the bottom of the fraction. So it's going to be minus. And then 2/6 reduces to 1/3, so it's going to be 1 over 3 x to the 3/2. We'll drop the negative because we took it to the bottom. And then lastly, we want to get rid of that fraction. So this would actually be written as 4/3 minus 1 over 3. And now the top is the power, so 3x cubed. And the bottom is the root, so the square root of x cubed. We don't need the 2 out there for the index because it's just implied with the square root that the index is 2. So that is our derivative. All right, and 2 more problems here. A little more practice. Let's go ahead and tackle this first one. F prime of x equals 6 times 4 is 24. X to the 5th power. This one, you want to view the square root of x as x to the 1/2 power. So that becomes plus 1/2 times 3 is 3/2. X to the negative 1/2. And then again, rewriting that, it becomes 24x to the 5th minus 3/4. Oh, sorry, no, minus 3 over, sorry guys, 3 over 2. And then this would be x to the positive 1/2 power. Positive 1/2 power is the same as the square root. So minus 3 over 2 square root of x. And some of these as well, if you remember from previous math, technically we actually should be doing even more to these answers because you're not ever supposed to leave a radical inside the denominator. So I guess I should say on the AP test, you wouldn't even see this answer. What would then happen is you'd multiply by radical x over radical x. And then so this would actually become 24x to the 5th minus 3 square root of x over 2x. Because radical x times radical x is just x. And so that would actually be the answer you would see on the AP test. You would obviously probably get this answer, then you wouldn't see it as an answer choice, so then that would probably make you second guess and think, oh, I need to do something else to get there. So try to do that the best you can. All right, last one here. Just like the one prior, we're going to rewrite this one. So we want to rewrite this one as f of x equals, break up this into a bunch of individual terms. And I'm also going to go ahead and rewrite that, the cube root of x as x to the 1/3 power. Make it a little bit easier. So there's going to be x squared over x to the 1/3 minus 5x over x to the 1/3 plus 2 over x to the 1/3. From here, I'm still going to want to rewrite it before I attempt to do the derivative. I'm going to subtract my exponents. So 2 minus 1/3, well, that'd be 6/3 minus 1/3, so that'd be x to the 5/3 minus 5. And this is 1 minus 1/3, so that'd be x to the 2/3 plus 2x to the negative 1/3. Now I can do the derivative. F prime of x, 5/3 x to the, subtract 1, that leaves us with 2/3, minus, we multiply 2/3 times 5 gives us 10/3, x to the negative 1/3, and then minus 2/3, x to the negative 4/3. All right, now I would want to rewrite all of these individually. This first one would be 5/3. Top is the power, bottom is the root. So it'd be x squared, cube root of x squared. Minus, this is a negative, so it's going to go down. 10 over 3. 1/3 power is the cube root. So cube root of x minus 2 over 3. Top power would be 4, so x to the 4th, the cube root of x to the 4th. So that's good. Again, you wouldn't necessarily want to leave that radical on the bottom. So what you would end up wanting to do would be multiply. So this would be 5/3 times the cube root of x squared minus, you would multiply this by radical cube root of x over the cube root of x. So 10 cube root of x. Actually, sorry, that would have to be, in order to get that to go away, you'd have to actually multiply it by the 2/3 power because it's the 1/3 power. So that would be actually be cube root of x squared. The bottom would be then 3x. And then the last one, since this is the 4/3, you would actually multiply this by the 3/4 power, which would be the 4th root of x cubed on both the top and the bottom. Get it to go away. So then minus 2 times the 4th root of x cubed over 3x. And that's a bit excessive there, but you technically should have those skills. All right, that will do it. The actual concept here isn't bad. It's just multiplying the power down, subtracting 1. But this is a good review over Algebra 2, basically exponent concept. So reach out to me if you are struggling, and good luck, guys.